Hello, welcome back. So today we are going to review systems of equations. This is specifically for Pre-Calculus 11 or Algebra 2, early Algebra 2 course. We're going to start with the easy one, then we're going to go ahead and look at another system. Now, remind you again that throughout the week, I will be posting new videos going through some review questions on different topics, and that goes right through from grade 9 to 12, including calculus. So make sure you subscribe or just come back to the channel and see what I have posted so that you can use these questions for your own review. All right, let's get on with it. The first system, we have this system, two linear system, and we want to solve this. And notice that I didn't specifically say which method that you need to use. You need to use whatever method that you like. And remember, there are three methods. One is graphing, the next one is elimination, the other one is substitution. Really, it doesn't matter which one you would use, but it turns out that if you are using elimination or substitution, obviously it's much more accurate. Now, graphing is great as well, but graphing, you must graph it very, very accurately, and unless the values, the solution to the system is an integral solution or kind of a almost maybe half, like 1.5 or 2.5 or something like that, you can see it. It's very difficult to get the exact solution through graphing unless it's an integral solution. Okay, let's go ahead and now let's solve. The first thing we need to do, you notice that we have to eliminate one of the two variables, or we can substitute one variable over another, but I'm going to use the elimination method. So I'm going to eliminate x in this case, but you could, by the way, eliminate y. That's the beautiful part of solving a system of equations, because you have a choice. So in this case, I'm just going to start with the x. So this is 3x, this is x. I need to be able to eliminate the variable x for both equations. So I have to make sure that this x has the same coefficient as this one. Then that way I can either subtract or add. So in this case, I'm just going to do subtraction. But the first thing I have to do, I have to multiply the second equation, this equation, all by 3, and that way I will have the same coefficient as the equation above for x, and then go ahead and do that. So what I will have, it will become 3x minus 6y equals to 18. So I multiplied 3 right through the second equation, and now I have the new set of equations, and this is 3x plus y equals to 11. And then the bottom piece, 3x minus 6y is equal to 18. And now what I will do, I'll go ahead and subtract. So we have equation 1 and equation 2, and then you subtract 1 minus equation 2, and what you will get, 3x minus 3x, that's 0. Y minus negative 6y, that is 7y. Remember, y minus negative 6y is minus minus beside each other, that becomes 7y, and then equals to 11 minus 18, and that is minus 7. Divide both sides by the coefficient of y, and you will get y equals to negative 1. Very good. Now that you have that, you just take that and substitute it back into the second original equation. Okay, let's call the second equation equation B. So this is equation B. Okay, so sub back into equation B. What we will have is x minus 2 times negative 1, and then we're just going to solve for x. So x plus 2 equals to 6, and then x equals to 4. So we have x and y both available, and we found it. Now we need to go ahead and check. Let's check that quickly and see that it's working. So here it is, we're checking it, and this time we're going to sub the values of y and x back into the equation A, the original first equation in our system. I call it A. And when you plug numbers in for x and y, you get 3 times 4 minus 1. Is that equal to 11? That's the question, right? The validity of this is being checked. Well, it turns out it is. So that is true. That is true. So that means our solution is a correct solution. All right. Very good. Let's look at another one. So this is a system of equations, 3 unknowns, 3 equations. This is actually not lined anymore in terms of graph. These are planes, okay? It's a 3D, we got X, Y, Z plane, right? But that's okay. We're just gonna go ahead and we're gonna solve this. Now, I do have to mention that this is also can be solved through matrices and solving matrices because this can be set up as a matrix. But for the purpose of this lesson and this walkthrough, we're just going to use the same method of elimination and substitution to solve this, okay, algebraically, that way. All right, so now the first thing I labeled these equations A, B, C, and then the first thing you have to do the same as before if it was 2 equations and in a system, you have to choose a variable to eliminate, okay? Choose a variable to eliminate. Let's suppose y. By the way, you can choose x, you can choose z, doesn't matter, but as long as you're consistent. So say y, we want to get rid of the y, okay? I just chose y randomly. All right, now you're just going to pair up the equations, 2 equations at a time, and then get rid of them so that your final answer or final equations will be with x and z only. So our new equations will be in terms of x and z only. And we know how to solve a system of equations with 2 unknowns, x and y. Okay, so that would be making it easier. All right, let's go ahead. So we're going to choose B and C first. So choose B and C. So we chose y to get rid of. That means we have to make sure that the coefficients are the same from the top and bottom. So multiply top and bottom. Sorry, multiply the second equation. This second equation, you multiply that by 2, and then you subtract the 2 equations. So when you multiply that, what do you get? Your C equation becomes 2x plus 2y plus 2z or z equals to 6. All right. Now your B equation, I'm going to put the B equation down here now. Okay. Your B equation is 5x plus 2y minus z equals to 3. All right, now we have this system. We're going to subtract 1. So 1 minus 2, equation 1, subtract away equation 2 from it. What do we get? So we have 2x minus 5x, that's minus 3x. 2y minus 2y, that is 0. So that would be plus 0. We're not going to write it. And then 2z minus negative z or z is plus 3z. And that's equal to 6 minus 3 is 3. Very good. Next step. Now we're going to simplify. So minus 3x plus 3z is equal to 3. Very good. That is our new equation. Let's call that new equation D. Okay, now we're going to go ahead and look at, pair up another 2. So the easiest one will be C and A. We're going to pair up. Okay, let's go ahead and pair up. So in this case, it's very straightforward. Notice that you already have negative y plus y. We just have to add the 2 equations, okay? And simple as that. We're just going to do that. So let's go ahead and add the 2 equations, and we get 3x. Okay, I put down here a plus c, so equation a plus equation c, and then negative y plus y is 0, and then we have 2z plus z is plus 3z. And then on this side, 0 plus 3 is 3. All right, this is equation A, B, C, D, E. Let's call this E. Okay, so this is equation E. Now we're going to set up a system of two equations and two unknown between equation E and equation D. Here it is. We have equation D is written like that. Equation E is 3x plus 3z plus equal to 3. And then now it's very easy. We just choose as a variable we want to get rid of. Well, x is just already set up for us. So let's do equation D minus equation E, sorry, plus equation E, because we're adding minus 3x plus 3x, that's 0. Then 3z plus 3z, that is 6z. And 3 plus 3 is 6. And z, or z, is 1. Very good. Take the z value, put it back into one of the equation D or E, and then find. So z equals to 1, put it back into D, let's say. All right, so we get negative 3x plus 3 times 1, that's equal to 3. Let's solve for x. Negative 3x equals to 3 times 1 is 3. Bring it over here, that's 0. So x is equal to 0, because when you divide both sides of the equation by negative 3, 0 divided by negative 3 is still 0. Now that we have z and x, we're going to go back to the original, one of the original ones, original equations, and then plug it back in there and then see if it works. Now we're going to choose the last one, x plus y plus z is equal to 3. So that's what we're going to do. Just making sure. Yes, it is. Okay. And now we have z and x. So we have 0 plus y plus 1. That's equal to 3. So y is equal to 2. Okay. So we have now all the three variables. Last part is to check our answer. So let's see if the first equation will hold. 2x minus y plus 2z equal to 0. And then let's check. Here it is. This is the equation 1, the very first equation, or A, equation A, and then plug in numbers for x, y, and z. And then what, notice that, is that true statement? Yes, it is. 2 times 0 is 0, minus 2 plus 2 is 0, so therefore, yes, it is. And therefore, we found all our three variables for this system of three equations and three unknown. All right. Make sure you go over these questions again, practice, practice, practice. Come back again for more videos throughout the week. Keep at it.